can't remember if this was the case when I was here last. I think it may have been, but I've actually, I've been in IT for about 20 years. I've been a consultant for about 15 of those years. And for the last couple of years, I've been running my own firm called Sam Newman and Associates. And this is sort of, I kind of work with this, it's mostly myself and my wife, who's my business partner, and we run the business together, and I do have a network of people I work with as well. But mostly it's work I do focusing on consultancy and advisory work for companies all over the world. And I also do sort of lots of private workshops. I'm actually here doing a private workshop for a client who's very close by to this particular room right now. They've been working me hard, and that's been really fun. Those are my three focus areas: was cloud, continuous delivery, and microservices. And so obviously for me, and I was into cloud way before I was into microservices, if that makes sense. You can argue that the original thread that brought me here was focusing on how to help people ship software more quickly. So 2004, I suppose, I started getting very interested in those aspects of continuous integration and what we now call continuous delivery. We didn't really have that term at the time. And it was all about how do I get the software from my laptop into a production environment as quickly as possible and as safely as possible. And so I was originally attracted to the cloud through that lens, that the cloud was actually the public cloud. I mean, not to offend any of you, but I would imagine that the private clouds that some of you use at work don't really justify the name. But for certainly the power we get from a public cloud provider and maybe some private cloud implementations to be able to on-demand provision infrastructure that allows us to host our applications, reducing the need for handoffs, allowing teams to get more done themselves was immensely empowering. And the public cloud and cloud technology in general has been really great at enabling certain things. You don't need the cloud to do microservices, but it helps. It's sort of the mantra I've adopted. And so microservices I got to because, again, it's an architectural style that helps you ship software more quickly. So there was that through line across all of this for me. But cloud native is one of our newest sort of big buzzwords. It's hit peak hype. I had a CEO at one of the largest clients I worked with last year, who basically came out and more or less said, we're going to adopt cloud-native architectures and microservices to reduce costs and deliver faster, which helps me understand immediately that the CEO in question had no idea what either microservices or cloud-native was, and hadn't yet grasped the fact that maybe completely changing how you develop software as a way of reducing costs doesn't really go together. But we didn't get to have that esoteric conversation because the architecture team I was working with were 5 levels below the chief architect, who actually reported to the person in charge of the company. So that didn't happen. But I'm here to try and maybe make sense of it all. And so maybe what I'm doing here in this talk is playing back my own sort of journey through what we now call cloud native and what that means. Obviously, when I wrote my book, I touched a little bit on cloud technology, but I always try and keep my book and the new one I'm working on, I'm trying to keep them a little bit away from technology-specific implementations because I think that stuff dates it. Cloud native, to an extent, might appear just a bit like a new term for an old thing, but we're going to get into that. But it is a very confusing term, the term cloud native. It feels a bit like digital native. Like a digital native, I think my stepson is technically a digital native, and I think digital native means they know what Snapchat is, but I haven't quite worked out all the details behind that yet. But there are 2 things I do want you to take on board before we go any further when it comes to cloud native architecture and cloud native computing, whatever you want to call it. The first thing is it's all about abstractions. Cloud native applications are just embracing a new set of abstractions that we didn't have in the past. The nice thing here is you just get to pick which abstraction you like the most. And like all abstractions, there are problems with this. And the second thing, this is very important, it's not all about Kubernetes. Because Kubernetes has been a big part of what the Cloud Native Computing Foundation have done, people sort of draw a conclusion. They draw a conclusion, if I want to be cloud native, I must use Kubernetes, which is rubbish. And the other conclusion people draw is, if I use Kubernetes, then I'm cloud native, which is also rubbish. But we'll get into that. So my own journey with the cloud started with Amazon. Amazon themselves, of course, have been around for a while. I didn't get involved really until about 2009, I suppose, when I first started working with the cloud. I sort of accidentally helped create the first ever training courses for Amazon. They were viewing what they did as selling utility. We just sell energy, effectively. You buy a computer from us, by the hour, that's it, that's our involvement done. What you do with that computer is up to you. But they realized quite quickly that the analogy of selling electricity doesn't really work, because it's like you're selling electricity, but then your customers are electrocuting themselves with it constantly. So they actually had to give you guidance. And you see this huge apparatus now around helping you understand how to make use of the public cloud platforms, because they are now incredibly complicated product suites. But back in 2006, which is when AWS first launched publicly, it was very simple. Two simple products back then. You had SQS and S3, both of which are in widespread use. I mean, S3 has been immensely popular. SQS is showing its age, but it's still there and in operation. But I think SQS was technically first, as the first ever public cloud offering from Amazon. And that was very interesting, because I think this was, people sort of talk about this idea that Amazon basically open sourced what they did internally. It's not quite that straightforward. If that was the case, SQS would not have been their first thing. This was them saying, we think we can sell cloud-based services. And they sold the queue, was the first thing they shared, which is a really interesting when you think about it. Of course, the cloud goes further back. I mean, the first time people, like your C-level execs, would have been hearing about the cloud would have been much earlier, would have been really the advent of SaaS companies. Salesforce was the first big SaaS company, really. I mean, as a company that was SaaS native. Interestingly, a monolithic application, Salesforce. No correlation between that and profitability, though. I mean, they're a company with a market cap of somewhere north of $60 billion. They've been a very, very successful company of a Java-based monolith. But they pioneered this idea of the cloud. And when I was working with teams saying we should use Amazon or AWS, people would be, I can't put my workloads on other people's computers. I don't trust those people. And the great thing for me was at those times, I could say, do you use Salesforce? And they go, of course we use Salesforce. We're a company. Also, all companies use Salesforce. And you'd be like, your data is already on somebody else's systems. You're clearly OK with that. Why wouldn't you be OK with this? And so as hard as those conversations were with maybe traditional ops people who often wanted to keep their machines safe, the genie was already out of the bottle. Multiple companies we rely on now to look after our data and our processing. And Salesforce started a lot of this for the larger corporates back in 1999, and it often gets forgotten. We talk a lot today about Kubernetes, which I think is understandable but unfortunate, because we also forgot what came before. A company with a recent linkage to Salesforce is Heroku. Who has used Heroku out of interest? Right. It's fantastic. I mean, let's be really clear. It is, to date, the single best platform as a service implementation we've seen as an industry. They nailed very, very early on the user interface, the developer experience for developers who want to build and host their own applications. There are all kinds of shortcomings for Heroku when it was first launched. I mean, it's expensive, right? When it first came out, that was often the limiting factor. But very early on, they nailed a different type of abstraction, from removing us from detail. AWS at this stage was like EC2, spin up a virtual machine, and then you can configure it using Puppet and Chef. And that was the state of the art. Heroku said, no, just have stuff in Git and run this line of code, and it's running. And it's like, the really interesting thing is the extent to which the application platforms that have come since have mostly either not learned the lessons that Heroku learned, or in some cases just gone, yeah, we'll have that. Cloud Foundry got completely and utterly rewritten to basically implement the same user experience that you get from Heroku. It's interesting now when you talk to developers who use Cloud Foundry day in, day out, they love the platform for the same reasons. Operations people tend not to love the platform for different reasons. But nonetheless, we have lots of prior art to draw up from. We didn't call these things cloud native. So what is a cloud native application? Well, the Heroku prior art we have here, which points the direction to what cloud native might be, is something some of you may have seen called the 12 factors. Is anyone here familiar with the 12 factors? Right. Heroku people definitely will be. This is always presented as a this is how you should build applications type thing. It was really created by the people behind Heroku. And in many ways, it's a mix of these are good ideas of how to build applications, and also you need to do these things, otherwise it won't work on Heroku. And that really is always what we're dealing with as architects, as developers. You've always got some fixed constraints you have to work with and some choices you get to make. And the 12 factors is a bundling of both of those things together. And as a piece of prior art that influenced other ways you think about the world, it's been really quite useful, very important. So some of these things, like talking about backing services, treating services you work with like attached resources, is actually quite an interesting idea. You're saying that's something else that somebody else manages, which sort of comes back in these ideas of independent deployability that we talk about with microservices. And talking about scaling by stateless processes was actually, in 2007, quite surprising. Or at least certainly for .NET developers and Java developers, was something that was quite alien to us. Ruby and Python people, yeah, we're fine with that stuff. That's easy. We've been scaling by process for years. I'm not sure what the PHP people have been doing, but they've been fine, right? But those of us in the .NET or Java landscape, we were deploying lots of applications into an application container. We were dropping things in IIS or, Tomcat, or if we're very unfortunate, WebLogic. And scaling our application by getting a really big machine and putting lots of processes inside it. And that's a model that's dying off rapidly. And again, Heroku was there very early on. They identified some of the benefits by isolating process, because you get isolation of provisioning of the infrastructure around that becomes a really important idea. So the 12 factors, though, isn't really about cloud native. It's about this is what works well on the cloud circa 2007, and this is what works really well, again, with Heroku. And to be honest with you, if you followed the advice there, you still do a pretty good job. I still don't think it's quite the same as cloud native, though. When you talk about the cloud native characteristics, it doesn't really quite match up. And that's partly because some of the things we take for granted now were only imagined back then. So I went searching around for other definitions of what might be cloud native. I found a group called the Open Data Center Alliance, and they have a maturity model. And I dislike maturity models for a number of reasons, one of which being it implies that higher levels are better, and secondly, there's a linear path there, and both of those things tend not to be the case. But it's interesting anyway. So they have these detailed levels. I've got to say, I'm not a fan of this at all, really, when you get down to it, because I think it sort of misses the point a little bit. But one of the things they talk about here is level 3 to be a proper level 3 cloud native architecture. And they touch here on one of the sort of the biggest misnomers, I think, around cloud-based systems in general. Here it is. The application can dynamically migrate across infrastructure providers without interruption of service. Yes, rubbish. Never happens. This is this idea we had early on with the cloud, because people were worried about that vendor lock-in. So we need cloud arbitrage. We need cloud brokerage. And when you look at teams that have implemented cloud arbitrage or brokerage layers, they realize it has a huge hit on productivity. Organizations as a whole may well have a multi-cloud strategy. You might want to have one team working with AWS, a different team working with Google to hedge your bets. That makes perfect sense to me. But trying to jump through hoops to create a platform or an application that can seamlessly transition across all of these different platforms, it's kind of a bit pie in the sky, partly because you can talk about cloud computing as being utility all you want. It's not really utility in the way we think of things being utility. You think about the power that comes out of the walls. In the UK, you can very easily change your energy provider. That system actually works really, really well. I can go to a website, compare with another company, click a button, and in 3 days, my energy is coming from somewhere else. Seamless. No one has to go and rip the cables out of my walls and replace them with different types of cables. No one has to get new appliances that handle different frequencies. It just works. Most of the computing resources we get from public cloud providers are logically equivalent, but not equivalent in terms of implementation detail. So you end up with all of this sort of stuff that tries to pretend they're the same things. Think of organizations that would not be adaptive according to this definition. Well, we can talk about Netflix, who are all on AWS, and Google, who run their own infrastructure, who would not be adaptive. They don't do arbitrage across different providers. Netflix don't. They might around bandwidth management. They do around their edge hosting, but not about the things that are on AWS. They're quite happy being all in. Does that mean we look down our noses at Netflix for not being adaptive enough? Well, no, it's a different type of success. So clearly I'm not helping, right? I have just explained what cloud native isn't as far as I'm concerned. So we should go look at the Cloud Native Computing Foundation, who actually do a lot of really, really useful good work. So the CNCF, for those of you who are old Java heads like me, it's Apache, but just for the cloud, right? That's basically it, right? An umbrella organization is actually under the auspices of the Linux Foundation, I think, who basically are curating a bunch of projects that work together to help build applications that use the cloud well. And that's sort of as simple as it is. Kubernetes was one of the first projects they helped curate. The idea being you get cross-company consensus around this to allow for some interoperability. We'll come back to that idea shortly. But they have a definition of what cloud native is, which is about as close as I've got to an official body having a halfway decent definition. But again, I'm not convinced about all of it. But we'll go through it. The first thing I say is container packaged. No. But dynamically managed, yes. Microservice oriented. I have a big problem with this one because they spelt microservice with a hyphen in it. And microservices does not have a hyphen in it. I've had the conversation. There is a change request underway to get this fixed on the charter. I need to follow it up and make sure it's happening. These are the kind of issues I deal with on a day-to-day basis, people. It's serious, serious stuff. But let's talk through these things. So container packaged. Why do we even bother talking about containers? Now, for me, I think this is silly because I think containers will increasingly become an implementation detail. But why are containers even in the mix here? Well, you know, there is certainly partly you get great clip art with containers. My friend Daniel's got all kinds of, like when containers go wrong presentation. And there's lots of pictures of container ships that are falling over and they look really fun. But there is this, they look the same, don't they? And that's actually kind of important. There's something about the uniformity of a container. You don't care what's inside it. That's useful. That gives you a unit of isolation. The first thing really is this idea of isolated execution. Even if you're not a public cloud provider, there can be benefits to running lots of different workloads inside containers because they allow for fairly cost-effective isolation of resources. Maybe not for some of you for different workloads from different clients or companies, because there are some concerns around security isolation of these things, although Windows containers fix a lot of those issues. But the idea is that you can much more cost-effectively break up a big machine into lots of containers that can run workloads independently of each other. And one container workload doesn't have to affect the other. So it actually tends to be much more efficient than virtualization. Virtualization, like type 2 virtualization that you see with something like VMware, makes use of a hypervisor. It's quite a different isolation model, has a much higher cost, so it's not as efficient when you want to really densely pack things together. Another angle that's really useful here is universal deployment. The shipping container system partly works because you have a standardized shipping unit. A crane that can pick up a container that holds grain can pick up a container holding a car. It's the same system, right? And so when you deploy a container workload on, say, a local Docker engine, you don't care if it's running C++, you don't care if it's running Java or Rust or PHP. What you care about is when it launches, it's on the ports, it says it's going to be on, and that's it. And that's pretty straightforward. That's a nice property. So again, if you're thinking about wanting to provide a generic platform for running different people's applications, targeting containers starts to make a bit of sense. And there is that other angle with the portability. Now, containers have been around for years, long time. You could argue that BSD jails were one of the earliest forms of containers. I think Solaris would argue that they predate even that. OpenVZ zones, which are actually closer in some way to vSphere containers on Windows. But you know, these units of isolation were better. Well, the thing that the Docker folks did, which is very smart and I think was often overlooked, aside from creating that nice command line for managing containers, is they came up with an image artifact format for the container. Before that, you had a script to rebuild a container. Now we have an image, like a VMware image, like an AMI image, and that can be portable across platforms. So that's really useful. So these things together, you start to see why providing a generic cloud-based resource for different people in different workloads, why this might start to make sense. The issue I've got is like there are loads of other things. If I built applications using a Heroku PaaS, am I not cloud native because I'm not using containers? What about function as a service? So I think function as a service is a really powerful cloud-based product that you get from a few different companies now that's sort of under the umbrella of serverless. You know, you've got AWS Lambda, which launched in 2014, Azure Cloud Functions, which I think in many ways are superior to Lambdas. And I say that as someone who's mostly an AWS person. They are using containers under the hood, but the containers are there as an implementation detail. In fact, I think Amazon recently open sourced some of the stuff they've done around, and Amazon actually are very bad actors around open source community contributions. It's good to see that shift has happened in the last couple of years. But they've opened up some of the underlying container engines they use for making these functions work. But with function as a service, you don't deal with a container. You say, here is a piece of JavaScript code, here is a piece of Java code, here's a piece of Python code. These platforms take that and stick it inside a container on your behalf and manage that container lifecycle and runtime on your behalf. So the containers are kind of there, but I'm not involved with them. So for me, the containers are just an implementation detail. So I think over time, this is where the world is headed. It may not be exactly fast for everybody, but I think in 5 years from now, you won't worry about a container. You'll worry about something else at a higher level of abstraction. And there are other people working on things like Heroku-like deployments on top of container-based platforms as well. OK, so maybe, but probably not in the future. And so I think this will increasingly be removed from the CNCF. And I do think is partly a legacy of them being more Kubernetes-centric at the beginning. Dynamically managed, this is where stuff gets much more interesting. This is where we start talking about applications where you're letting the platform make decisions on your behalf. You're saying, I want 5 of those things, and it will make sure there's always 5 of those things for you. You don't have to do anything else. You can set up auto-scaling rules. Things like FAS, their deployment models are incredibly simple. Run a function and connect it to these types of events. And when one of those events happens, one of those functions gets launched. You are not involved with any of that process whatsoever. This dynamic managing side of it, and I think FAS is the best example of this done well as an abstraction, as a conceptual abstraction, is fantastic. Drastically lowers your operational overhead if your platform is good, right? And this is, unfortunately, this dynamic management aspect is often one of the areas where people's private cloud implementations really hold them up. I've seen plenty of private cloud implementations that don't really have these concepts built in, that might have barriers put in place in terms of how you can provision infrastructure, like where you still have to raise a ticket to launch a new container, right, in some extreme examples. I did find a good counter example. I found one client I worked with recently was using AWS, but none of the developers knew they were using AWS, because if they wanted a machine, they still had to raise a ticket in Jira, which I had some very firm words with the CIO at the time. Anyway, so in general, that's often the area where private cloud implementations can suffer as a result. And we've already discussed the lack of hyphens in the official definition of what microservices are. That conversation is ongoing. So Cloud Native Computing Foundation, that dynamic management is fine. A platform doing dynamic management for you, that's good. Maybe container management, but I'm really not convinced. Pivotal also kind of bundle in both containers and microservices into cloud native architecture. And for me, again, microservices don't seem to fit totally well in this scheme, but Pivotal are also, they're nice folks, they mostly know what they're talking about. So they put it in there as well. They've thrown DevOps and continuous delivery in there as well, which feels like it's like you've got all the buzzwords we've got knocking around the office, or just put them on one slide, and we'll send that along. I can say things like that now because I work for myself. I'm only letting myself down. So let's look at microservice-oriented. Why do people care and talk about microservices in the context of cloud? Well, as I said before, you don't need to do the cloud to do microservices, but it sure can help. Partly because having a platform that allows you to automatically provision parts of your infrastructure can drastically lower the cost of owning a microservice architecture. If you still have to go through and jump the hoops of getting boxes provisioned every time you want to create a new service, you're not going to have many services. And so a microservice architecture is going to be a harder time for you. So it can lower the cost of creating and managing services. So that goes well from that point of view. But does that mean that cloud native means you have to do microservices? I'm still not super convinced. One of the things that microservices open up is the possibility of independent scaling. This is a useful property. And more to the point here is kind of what we can call right-sizing. I can take a service and scale it to the appropriate load and scale it on the number of machines for the appropriate, say, robustness that I'm looking for. A service which has low load and doesn't have to be up all the time, I can run on a certain type of cloud service. A service that needs much more uptime, I might be running out of more machines across maybe 2 different data centers across to a cloud provider, or even 2 regions. And so there is something there which is, if I've broken my solution down into these smaller services, I can better match the scaling requirements of one service against that cloud platform. It also allows you to look at right tool, right jobs. So as you break things down into microservices, you might find pieces that can be pushed almost entirely into cloud-based providers. You might, for example, find that you can just run this particular solution entirely on functions, which can have some huge cost implications. I think this is actually the area where cloud native and microservices goes together better, is this idea of independent deployability, which is a key idea behind microservices, that I should be able to take a service and deploy that independent of anything else. If you think about a lot of the cloud-based services, things do auto scale. For that to, work, I've got to be able to spin things up. Well, how does that work if I've got a distributed monolith? Right? I don't know how can it work. So this still opens up a lot of that dynamic management. The dynamic management aspects from a public cloud provider and the independent nature of these microservices, I think, can go very well together. I'm still not convinced that you have to do microservices if you want to say your application is cloud native. If your application handles and scales load dynamically based on what your users require, just because it's a microservice doesn't mean it's not cloud native. So again, beware of buzzword bingo. We can try NIST. Now, NIST in the US actually do have a model for what they call cloud computing. Not cloud native, but cloud computing. And I think this is one of those areas where often the private cloud vendors miss a trick, because they talk about what it is you need to have to even claim to have cloud computing. There was the recent State of DevOps report by Dora shows something like that high-performing IT teams are over 20 times more. No, so yeah, they are 20 times more productive than those teams not using cloud platforms. So cloud platforms are incredibly strongly correlated with high-performing IT teams. Right? Very, very good evidence for that. Very, very good evidence for that. But of course, not everyone's cloud platforms are equivalent. We talk about a good cloud platform, on-demand self-service. Bam, there goes the majority of private cloud setups I get to use. But maybe you've got that. Broad network access to a variety of devices. Again, this tends not to happen very often. Resource pooling, maybe. Rapid elasticity. Again, that's sort of an issue, isn't it? How many containers are you allowed to have in your OpenShift console? Someone's giving you, you've been a good boy, you can have 5. You've been a naughty girl, you can only have 6. And like you tracking stuff like bean count. Anyway, measured service as well, which is pay as you use, right? So these are sort of the NIST characteristics of what cloud computing is. And I think just not from cloud native and cloud computing. And I think the vast majority of private cloud setups I use, even if, oh look, we've installed Kubernetes, doesn't actually satisfy these core requirements. I still haven't answered the question, have I? What is a cloud-native application? I'm getting there. It took me a while. I'm still to work all this stuff out. Let's think about the evolution of our use of the cloud. These are the different ages of evolution, maybe, I don't know. But we start off with the lift and shift. Right, the lift and shift. I used to fight against the lift and shift, but I realized it's probably not always the right thing to do. The lift and shift is where you take an application that was never built with the cloud in mind, and you pick it up, and you drop it from a great height onto some sort of cloud platform. And it doesn't quite work, so you sort of put your foot on it, and you wedge it down, and you hit it with a hammer, and you slap a configuration file across it, and you cover it in duct tape, and it's running, and you go, she'll be right. Right, what's next? Now, obviously, the issue there is often you end up with higher costs from an operational point of view. You're putting applications onto a platform that weren't built in the right way. So you've got this impediments mismatch. Things don't quite work properly. In one famous example, I remember one of my clients just took VMware export images of their entire production stack and imported it onto AWS. But still had to configure everything manually by logging into Windows operating system UIs and clicking buttons to make anything work, right? Now, that's obviously a crazy use of the cloud. It's missing the point of what people like AWS have been pioneering for such a long period of time. Sometimes it's still the right thing to do. If you've got to shut down a data center, sometimes that's the right thing to do, right? So I kind of clarify this lift and shift. Is you're on the cloud, but no one's happy, right? The application is actively fighting being there. I was not designed to do this. This is not good, and nobody's happy. And my favorite example is I was working with a team and we were moving this whole data center out onto the cloud. And one of the products they were using, I think, was handling payroll or something. And this was a license-based piece of software. And if you stopped the VM and started the VM, the fingerprint of the machine changed such that the licensing software said, you've installed me on a new machine. And so then you had to phone up somebody in the UK. We were in Australia. We had to phone someone in the UK to get them to reissue a license file. So just something as simple as stopping and restarting it, not a shutdown, not a redeployment, just pause, play. That was enough for the licensing software to go, oh, no, the world has ended. Right. No one was happy with that. We ended up putting it back on a normal machine because it was driving everyone mad. We've then sort of got cloud ready, which is I've taken the edges off it. It fits a bit better in the box. It's no longer actively fighting the cloud platform we're talking about. And this is sort of working with and not against. And this is sort of where I think the 12-factor apps are. 12-factor are cloud-ready apps, right? You build with cloud native, so with the 12 factors in mind, it's probably going to be fine. You're probably actually, most cloud platforms, you're going to find a good fit. So you're working with, not against the cloud. The cloud native application for me is embracing the cloud and only the cloud. And what I mean here is you've picked a particular cloud abstraction and you have built it with that cloud abstraction in mind. You're getting the best out of that abstraction, but you're likely to have pain if you wanted to change the abstraction you're using. So 12-factor apps up here. And a great example of this would be some of the serverless offerings out there. If I have built an application that is making use, for example, of Kinesis and SNS and FAS on AWS, I'm getting the most use out of that cloud platform. I'm getting huge amounts done for me by the underlying vendor because I've chosen a cloud abstraction. It may not be a great portable one, but I've picked one. Right. So an application that is built to take full advantage of the underlying cloud platform. We're really trying to push as much work as possible off onto the platform itself. This probably means you've designed your application, or at least evolved your application, with a specific deployment platform in mind. And it's quite likely not going to work without a cloud platform underneath it. Okay. So you could pick Kubernetes as your abstraction if you wanted to. That's fine, although we then have to have the conversation about what flavor of Kubernetes you're targeting. But that's an abstraction. I don't think it's a very powerful abstraction when compared to some of the other things that are out there, but it's still pretty good. It's definitely better than what we had in the past. So characteristics we're going to see. These applications are built to scale, or at least built to be scaled. We may not have done all our tests, but we think we should be able to spin these things up, right? Spamming out more nodes is going to be fine. Fault tolerant. This should be, yes, but often people assume fault tolerant means the platform can magically do it for me, and the application has to think about it yourself. Maybe decomposed into services. I think that makes it easier to take full advantage of the underlying cloud platform, but clearly pushing work to the platform and being highly, highly automatable, right? You're looking to push the work to a platform that somebody else manages. You're looking to buy into somebody else's abstraction. When you do that, you get all this cool stuff, which is called free time, which you can use writing new software or going to the pub or skiing, whatever you want to do, right? What you lose is control. When you buy into somebody else's abstractions, you end up losing control. When you run a Lambda function, for example, on AWS, the one thing you get to control, the only thing you get to control is how much memory you give it. That's it. That's the one. You get one dial with that. And the more memory you give it, the more expensive it costs. That's it. Can't do much else with it, really, when you get down to it. You can't say how big a CPU it's got. No, just a memory. That's all you've got, one dial. Now, there's power from that abstraction. There's a lot of power from that abstraction. But some people find those models overly restrictive. So platforms, this is where your abstractions are. Whose platform are you picking is whose abstraction are you buying into. Which person's mindset or which company's mindset matches yours the most closely. Or do you want to hedge your bets and maybe go with an open source platform, which you might have to do more work on, but theoretically gives you more portability across vendors? And we've been playing with these abstractions for years, right? I mean, if you think about the early days of the public cloud offerings, a lot of the focus is this thing called infrastructure as a service. You think about a managed virtual machine. You think about those, you think about network storage and compute, those sort of three primitives of IaaS, the early days of cloud platforms. It's really interesting when you look at it now to think that the first two cloud offerings from AWS actually weren't IaaS. They're really what they would now call serverless. And that was back in 2006. On top of this, we've kind of got a higher level abstraction. We've got container orchestration as a service. This is your managed Kubernetes platforms. This is where rather than saying, I want one of these machines, please give me this machine, instead you say, here is a container workload, I want you to work out how to run this on my behalf, and here's a bit of hints. So EKS, ECS on AWS as an example, or there's 2 or 3 different cloud container offerings on Azure. But again, so we've stepped up a level. I'm not worried about the virtual machine, I'm now worried about my container. So it's high level operating, high level abstractions, hopefully more power, but I've lost some ability, I've lost some tinkering. On top of this, of course, we've got platform as a service, which is getting closer to just worrying about your application. This is where Heroku was always aiming. And I'd argue that when you look at serverless and the banner of stuff underneath serverless, what we've basically got is if the infrastructure as a service primitives were storage, network, and compute, serverless is all of those different primitives that help us build platform as a service offerings. Messaging as a primitive, for example. Functions as a primitive of how you build a platform as a service. And sort of, we've got Kubernetes is wandering around in the middle, right? So Kubernetes, depending on how you look at it, is maybe trying to shift up top, but I think that's stopped mostly now. And this is not new, right? Developers have been doing this for years. This is what we do, right? Somebody gives us money. We use the money to buy coffee. We use the coffee to turn things into abstractions. That's what we do. This is not new. We started with the abstractions of machine code, and then people thought, oh, this is a lot of work. It's a bit painful. What if we came up with a high-level abstraction? We came up with assembly. Now, assembly gave you less power, arguably, than machine code. And some of the machine code people go, look at these new kids using that assembly code. They don't know what a real programmer is. And all the assembly code people are going, oh, look at you stuck in the mud. We can get so much more done with assembly code. And then, of course, we came along application code. We're talking programming languages like Python, and all the machine code people and the assembly people are going, oh, look at what's happening to the world. They don't understand how to decrement a register. I just about remember, I think, how to do that theoretically based on something I once written in a book, right? But we mostly operate up here at this level now. Very few of us work low down, because most of us don't need to be that close to the underlying metal. In fact, most of us want to be an abstraction layer, so we don't have to worry about that anymore. And we, in exchange, are hopefully a bit more productive, a bit happier about the world. The cloud abstractions are just the same. Now, of course, there is the problem with abstractions, is that sometimes abstractions let us down. Sometimes abstractions are leaky. Sometimes we have to know about the underlying platform, and in other words, to tinker around the edges. As a very, very simple example of what can sometimes happen when you have leaky abstractions is people realizing that when their Lambda function isn't running, it can sometimes be running, and sometimes it can still be leaving network connections open. Unless you know that about Lambda, you might fall into some odd mistakes. So Joel's not always a fan of abstractions, which, I don't know. One of the other things that concerns that people get about abstractions is they'll get stuck somewhere. Right, I'm locked into a situation. I can't go anywhere. This has always been the argument about every platform and every vendor for as long as I can remember. Oh, what happens if they change the pricing model? We've only got what? 14 years worth of experience with, say, AWS as a cloud provider. I've never once seen them increase the price of any of their services. More to the point, I've never even seen them turn any of the services they provided off. And that's actually a problem, because SQS is kind of sucky, right? But they have to keep maintaining it. It's only got better since 2000 and 2006, right? So I don't know about that. There's also, there is the extent to which cloud providers can do things better than us. They have a concentration of expertise, and they have economies of scale, which means they can handle things better. Some of you may have heard of Heartbleed and Spectre. All the public cloud providers had those patches applied within 7 days of them being released across their entire infrastructure. You knew that had happened because all of your machines got 30% slower, but they did it, right? And that's the issue. Our deployment platforms, especially for microservice architecture, are getting more complicated. You've got your hardware, and on your hardware, you've got your operating system, and then on your operating system, you've got your hypervisor, and then on your hypervisor, what have you got? That's right, your virtual machine operating system. On your virtual machine operating system, you're probably running Docker, right? Because you're a cool kid. Cool kids, hanging out with cool kids. Docker, and I've got my application operating system is sitting on top of my Docker, because Docker does run a full operating system inside it. It just has a shared kernel. And on top of that, you've got your applications. And then you suddenly realize that all of this giant stack of horror has to be looked after by somebody and patched by somebody as well. Now, of course, if you buy into a cloud vendor, you can offload all that, have somebody else deal with it for me. That's a nice thing to do. So, yes, you've lost power. Yes, you've ceded control to somebody else. Yes, maybe you're even locked into somebody else's system. But sometimes being stuck somewhere is a nice thing, right? There are bad walled gardens and good walled gardens. I'm an Apple person, not a massive fan of the company per se, but just I like being in that ecosystem. It's the equivalent I've got. It's not like the old nasty walled gardens I used to find myself in. It's like a nice walled garden where people bring me a drink and I sit by a nice babbling brook. It's very nice. I can't leave, but it's a pleasant place to be. I've been in other walled gardens where it's a very scary place. It's always dark. There's no lights. I can't see anything. There is a babbling brook, but it's full of what I don't want to look at. And there's like monsters trying to kill me. So there are good places and there are bad places. And hopefully, if you're stuck on Amazon, there are worse places to be stuck. Let's come back to the Cloud Native Computing Foundation and the work they're trying to do. Now, very early on, AWS focused on this idea of primitives. Primitives are how they see the evolution of the AWS platform, which I think early on was its success, but I think is ultimately might be at least eroding some of their success. And they said rather than providing a single monolithic platform, instead they're going to provide these primitives, starting off with things like network storage and compute. The idea being is that you can buy into those primitives that you like from AWS and then replace them with the things you don't. So you can mix and match. That way it gives you a lot more flexibility in how you use a platform. They actually they evolved higher order abstractions, higher order primitives by combining the lower order primitives. The challenge, if you think about those primitives, we think about, EC2, Amazon S3, and RDS, right? RDS is an example of a higher order primitive. It's a primitive which is a managed database instance. Under the hood, they're standing on top of the managed primitives of EBS, the Asset Block Store Device, and EC2. The challenge with this is they're trying to iterate themselves to more highly abstracted abstractions from the lower level things. And I think that's also why a lot of the developer experiences of Amazon technology is quite poor. So not really thinking outside in terms of usability, but it's being really successful. Because it means if I come to your platform and I like 80% of what you do and I don't like 20, I can take the 80 and do the 20% myself. And that's really helped them in terms of adoption cycles, right? The Cloud Native Computing Foundation, to an extent, are doing the same thing for cloud native applications. What they're doing is just identifying these higher order primitives, identifying projects or classes of projects that are needed by people when they want to build a cloud native application. Now, they've adopted the idea of it being container managed. I think that will fall away over time. But there are certain problems that need to get solved to build platforms and cloud native platforms. And certainly, the focus of the Cloud Native Computing Foundation has been in terms of being platform agnostic. So the idea isn't to say there should only be one tool for each job. It's more to say, when we talk about this job, this is what we mean, and we're going to strive for interoperability between those different platforms. So there are multiple choices from container runtime, and I think even secret storage, and there's certainly there's a couple of different service meshes, Linkerd, and Envoy is not a service mesh. That's wrong. Anyway, have that argument separately. This idea of cloud agnosticism seems great. We are going to be vendor agnostic. Aren't we brave? Vendor agnostic. It's sort of good because we're not locked into a vendor, but we should also remember where Kubernetes came from, right? Kubernetes, the altruistic view, was Google wanted to give forth some wonderful technology to the world. The cynical view, which was Google was realizing it was distant third on the public cloud battle. I mean, a distant third, and remains a distant third, was worried about the existential threat of Amazon being the only place that people ran public cloud workloads, and so released some technology that they hoped would allow people to be portable across cloud vendors. And that's actually worked out pretty well. Yes, something like over 65% of all workloads of people running Kubernetes workloads appears to be on Amazon, but it's working, right? Because at least you can kid yourself that it's portable. Anyone want to guess who the first public cloud vendor was running Kubernetes? It was Microsoft. Very early days, right? The Cloud Native Computing Foundation was missing a proponent for quite a while. Every other company was on board. Every other company until one. Amazon joined very, very late on. year before last. They didn't need it. Everyone else needed it. They needed to create a groundswell of opinion around a more generic platform to give people the ability to move away from AWS. Amazon don't care, because they'll just go out their way to create a really great Kubernetes experience that you want to stay with, and it seems to be working right now. This is one of the nice ideas that people like about things like Kubernetes. I can have my on-premise cloud. I can have a fantastic cloud platform on my own machines. And the problem with this is, well, experience. I mean, we've been here before, haven't we, with OpenStack? Because that worked out fantastically for everybody. On-premise, you've got this whole operating cost thing. Can your staff, with the best will in the world, be given the right support and resources to do as good a job of operating and maintain that platform as Google, Amazon, and Microsoft, and DigitalOcean, and whoever else can? Maybe, if you're very lucky, but it's unlikely. It's unlikely you're going to get that. The other problem is that most on-premise cloud providers are still stuck in the world of lower order primitives. They're not giving you the really cool higher order primitive stuff we expect. When you look across the Cloud Native Computing Foundation's projects, there's notable gaps here, there are huge gaps actually, when we think about what we get from the public cloud providers. I can take all of this and hook it together and run it on my own system, but there's gaps here. Right? Where's data? Where's storage? Turns out data and storage are really hard problems to do on-premise well. Now, for me kicking it earlier, OpenStack at least tried to deal with that first up as one of the main problems that they dealt with. Something like Amazon S3 is conceptually incredibly simple. Providing that on-premise is very hard and typically involves cutting a 7-figure check to NetApp for a big machine and lots of disks. Right? These are the gaps. This is the stuff that we don't think about. What about a managed data plane? Just something as simple as RDS on-premise. Is that in the Cloud Native Computing Foundation portfolio? No. It would be if they could find the projects, but no one's building it. Even at the level of just disks and data management, the things aren't going well. We're seeing startups go to the wall because they can't make a business out of this stuff. So I'm still kind of, I love the technology they curate, do not get me wrong, but don't kid yourself that you can pick this up, drop it on your private cloud platform, and then end up with an offering that's as good as what you get from the public cloud providers. Doesn't matter how much money you give Redshift, IBM now. It's IBM. I get confused, right? And I'm sure IBM are going to make a lot of money selling to the same people that brought Bluemix and just selling them now OpenShift instead. That's going to happen, right? That's why they bought Red Hat. You're going to pay a lot of money and you're still not going to get there. So I would say, in all seriousness, really do re-examine whether or not you need to be on-premise. Some people absolutely do, I get that, but for many you don't, and your lives would be better off if you weren't. To talk about standards briefly, one of the things that Cloud Native Computing Foundation is trying to do is to try and develop standards for the kinds of problems or solution spaces that we have inside building cloud native applications. Now, again, we've had lots of standards bodies before trying to do this, and it hasn't always ended well. I mean, I lived through the SOAP WS star stuff, right? And great work and lots of engineering didn't necessarily deliver on things that were always a benefit to us as developers. I think partly because often the way in which we approach the creation of these standards. A good example, I think, is being done well would be something like the Open Tracing API. So the Open Tracing API was actually extracted effectively from a tool called Zipkin. So Zipkin is a really cool tool that helps you do distributed tracing. So it's actually a tricky problem to do well, in terms of how you trace calls through a system, determine accurate timing and all those sorts of things. But that's kind of a hard thing to do well. Zipkin was created at Twitter, did a really good job of doing that, and they came up with this Open Tracing API by looking at a real-world use of this thing. This works, let's pick up that as the standard. And that's the right way of doing it. Let the standards emerge from real-world use. You've now got a variety of different technology out there that supports the Open Tracing API, both commercial tools and non-commercial tools. Most people now actually would pick Jaeger as an open source implementation of an open tracing API rather than something like ZipKit nowadays, but things like Datadog support it as well. This is a good example, I think, of what the Cloud Native Computing Foundation are doing well. And as I said, they have loads and loads of members. And yes, there is Amazon there on the top left. And this is good. There is some great smart work being done. There's an awful lot of there's a lot of goodwill going on. There isn't too much vendoritis going on either. And I know quite a few people involved with this. And it really, I think they're doing an excellent job of trying to corral all of this stuff. And it's been much more successful than some of the earlier industry events I've seen. It's sort of interesting because I come back to this sort of slide every now and then. It's like, are we just collecting together buzzwords, or is there something else going on? We've got abstractions building up on abstractions. I think we've kind of got ideas and concepts building up on top of ideas and concepts. I've sort of, in the last 20 years or so, I've been around where lots of interesting things have been happening. I think it's just purely coincidental. It's got nothing to do with me. I was just there when it happened, right? If you think about it, the emergence of agile and lean development as being a sort of course, it's now the de facto way of how you create software, even if people are still doing waterfall a lot. But, agile and lean. And, agile and lean gave us DevOps to an extent. The mindset about breaking down barriers, that cultural movement that comes from DevOps was very much inspired by the idea of some of the ideas coming out of lean and agile, as was sort of continuous delivery. Continuous delivery comes straight out of the Agile Manifesto. It's one of the 12 principles no one ever looks at. You've got the four things on the first page. Second page is the second page of the Agile Manifesto. It's there, you should read it, it's great. Continuous delivery came straight out of that. Of course, continuous delivery and DevOps really influenced and reinforced each other. Distinct things, but there's a lot of overlap, right? Reinforcement of ideas. If you think about the public cloud providers, that technology was created to enable that kind of delivery thinking. You wouldn't come up with a public cloud provider unless, with the public cloud offerings, unless you thought, wouldn't it be good if developers could provision their own infrastructure? And why would you want to do that? So you could go faster, so you can improve autonomy, so you can get things done, so you can avoid handoffs. Amazon, wanting to work the way Amazon did, which is very much built on sort of lean thinking, they needed something to do that for themselves, and they thought, well, we should make some money off it while we can. And boy, oh boy, have they done that, because it is very profitable for them. Microservices at one level are not a new idea in any way, shape, or form, and you'd be totally appropriate to say, it's just basically modules with networks in between, and you'd be right. But we couldn't do modules with networks in between very effectively back in the 60s because of the technology implications of that, and because of the working practices. We didn't quite have our heads around some of these ideas. Microservices has been made possible by all of these things. Again, you do not have to do these things to make microservices work, but microservices wouldn't exist without that prior art. And I think when we think about cloud native applications, it is to an extent trying to bring all of these threads and all of these ideas together. Just taking strands and ideas and bringing it all through. Also, depending on how you want to view it, maybe giving up a whole lot of power and autonomy to one of a small number of very big technology companies. Are you happy with that? I'm not sure myself. I go backwards and forwards on this one a lot. Like, Lambda's pretty good. Cloud Functions are awesome. But do I want all of my stuff running on someone else's machines? There's still a bit of me that's not so sure about that. The nice thing is nowadays we've got more of a choice. The starkly different choice between running your own OpenStack setup, which normally involved like getting a big company like Fujitsu, or to take all of your money, versus AWS is a huge gulf. That gulf has closed a little bit, but as the private cloud offerings have got better, so have the public cloud offerings. You might not be happy with that, but there is still a big, big gulf between the experiences that you get from those two platforms. So, is building cloud native applications for me, right? Well, you've got to be okay with buying into a platform, right? You really have got to be okay to buying into a platform. And you're probably also going to have to get a bit smarter about continually assessing the new technology that's coming out there. And that's just a good idea anyway, because there is so much stuff coming out there, and especially the stuff that's happening in the function as a service space has profound implications for how we design applications. If you want to embrace this stuff, there are lots of new skills you're going to have to learn. You might even need different types of people, which is more of a scary thought. Lots more work to be done here. People wanting to take on different responsibilities that they didn't have before. If you're worked in an environment where you're used to handing something off to an operations team, do you still do that today? Is that how you want to work? Or do you want to be more empowered with this stuff? It also changes the role of operations people as well. Are you now doing all the work, or are you helping other people get their work done? It's a big shift. And that's a shift we've been going through for the last 15 years, right? And the other thing, of course, here is you're going to have to accept some of these constraints. If you're going to buy into someone's platform and buy into their abstraction, you're going to get more stuff done, but guess what? You can't go and tinker with your own machine code anymore. How much you're happy with this is down to you. You may just have to pick a lower level abstraction because you need more control and power, but just accept you're going to have to do more work yourself. When done well, you're building applications to the cloud, especially if you're embracing the serverless technologies, then you have the opportunity to rapidly reduce your operating costs in terms of operational overhead, not necessarily in terms of how much money you give Amazon, right? I know OpEx comes out the same budget, right? But if I'm spending less time worrying about patching machines and more time writing code, that's normally going to be a net win for everybody. It should also therefore allow you to move faster as well. I can scale up, scale down, I can quickly throw applications up and out there without having to jump through too many hoops. And hopefully, handle scale, and I think often overlooked security aspects significantly better than if you were trying to do these things yourself. And I think that's one issue where it's pretty hard to argue around, is that there are some just the basics that are actually quite challenging to do in today's deployment topologies. And having people that just think nothing other than how to handle that stuff on your behalf, who you're paying, a few dollars an hour for the privilege, that's a pretty good return on your investment. I've got loads more stuff out there on this stuff. I've just done a video series for O'Reilly on microservices and serverless. So if you sign up to the O'Reilly bookshelf, which you can get for free for a 30-day trial, you can watch this whole 3-hour tutorial, which is broken down into sort of 5 and 10-minute sections. The idea is you can watch it while your builds are compiling. For those of you who use Python where you don't have to wait for builds to compile, like me, you can't watch the video. You have to wait till your evenings because we're just too busy being productive. But if you have to wait like some kind of Neanderthal for your code to compile, then yes, this video might be for you. There's other stuff up there, and so they've got some great overviews more on cloud native and people doing deep dives into how to build cloud native applications with different stacks. So do take a look. And again, you can binge for 30 days and no one will charge you. And that means you can save enough money to buy a couple of copies of my book, which I think everyone will be happy with. Thank you so much for your time. I've got a little bit of time for some questions. But I hope you've enjoyed the talk today, and thank you. Okay, probably got time for a few questions. Anyone wants to ask any? What is that? What's that?
It's my phone.
That's a box.
Yeah, but you can throw it around and it's soft and it won't hurt anyone.
That seems like it's taken some of the fun out of throwing stuff, though. If you
throw it really hard,
Now you're talking. Okay, who wants a box thrown really hard at them to answer? Anyone got a question? Okay. Well, there we go. Go ahead.
How come you don't have HTTPS on your site?
Old slide. I also like trolling Troy when I see him for presentations. I'm always promoting HTTP. AS stands for slow. Yeah, just purely a typo. Don't worry, my site will automatically redirect you over to HTTPS. And I think I've got HSTS set up. I'm preload. I've got preload set up. Anyway, yeah, I'd never lived that down. But good spot, thank you. I'll fix that slide. Okay, go ahead.
Not so much related.
Oh, do you want to throw the thing? Because there might be people on the stream.
I don't think it works.
Okay.
What are your thoughts, if you have any, on use of workflow for orchestrating microservices in a setup like that?
So I think my views really on that are the same as with all kind of BPM type solutions. So probably thinking of things here like, arguably Lambda step functions fall under this bracket as well. So where basically you've got different services that play different roles, and you've got something else that tells them how to work together. So BPM is a business process modeling has been one way of achieving this, where often you'd have a tool chain that allows you to come up with a graphical representation of how these things are going to interact. The idea being that non-technical stakeholders would design your process flows. You as a developer would create the low-level thing, and they'd pull it all together to make something big happen. And there's some nice ideas with that sort of stuff, right? Having the visual representation of that stuff is awesome. Loved it. Love it. It's great. The challenge I've always faced with those things is that it's never a non-technical stakeholder that ends up creating those flows. It's always a developer. And some of those BPM tools historically suffered from things like not playing nice with version control, often because they created file formats that were often binary or couldn't even be diffed easily, often being hard to test and not developer friendly. And sometimes actually just writing code is a nicer experience. And so I still have those concerns. And so the things that are offered by the cloud vendors, they're a little bit, I don't have all the same concerns in as much as they're slightly more developer friendly, but I still have those same issues. The other problem with BPM and sort of those orchestrated based solutions is that they potentially give you a place where business logic can become centralized. And so what can happen in those environments, not always, is that the services you're talking to don't really have any smarts of their own, and they've all become embedded in these sort of these workflows. Now, again, the simplicity of some of the cloud-based providers makes that hard to do in some of them. Right? In some of the situations, it's quite hard to centralize much in something like, say, step functions, for example, which are very simplistic in what they can do. A really interesting take on that, you should take a look at Azure Durable Functions, which on one level look like step functions, and on the other level are totally different. So with Azure Durable Functions, you basically just look like a normal function, but then you can await on other things happening. So you just write it in C# code. And so I say, I'm going to wait on that function. And what happens when that happens is your function gets suspended, and the entire state of that gets suspended too. And when that function completes, they re-invoke your functions. It's much more like continuations, in fact. It's a really powerful model. And the underlying architecture opens it up for other different kinds of platforms. And that should theoretically allow you to orchestrate through code. So I have the same concerns. Definitely take a look at some of them. But yeah, the concerns really are, who is the audience for this, and what do they want? And if you really, really have to do your own BPM, something like Comunda's not bad.
Thank you.
You're welcome. Anyone else? There's a question right at the back. So let's see. There we go. Oh, look, it's a relay system. This is great. I like this.
So you mentioned that we should maybe choose cloud solutions over on-premise solutions. But how do you, for example, balance when your product actually is, the product that you sell is on-premise solution in its offer? So how do you convince your managers or sales that actually that model maybe should be abandoned in a sense?
Yeah, you're not going to win that one if you're the one pushing it. I've actually worked with 2 separate clients in the last 2 years who, as a product direction, are moving away from on-premise delivery. So I think those types of things are different because that's part of a product strategy. So if you come and say, actually, what tends to be happening is that having to install the software on customer premise becomes a barrier to engaging new customers. Often it's work. I have to go to your premise. I have to talk to your operations people. We have to install that software together. You have to learn to support and manage that software. So there's like a level of effort and buy-in that is required in those situations. Whereas, go here, click button. You have access to our app. That SaaS-based serotonin hit is a much easier customer acquisition model. And so for me, a shift, if you're doing on-premise installations, then a few things. Firstly, you're going to have to be much more modest in how aggressive you are at microservices. Microservices are a pretty terrible option for on-premise deployments. But you may well find pressure coming from your product side. So if you are interested in agitating, I would be saying, are we thinking about doing a SaaS-based version of our software? There's also kind of an intermediate ground where you can think of single tenancy SaaS, and this can be a migration path. This is what I was talking about with my clients, which was our software isn't built to be a multi-tenanted SaaS-based software. It's supposed to be built and deployed on premise. What we could do, though, is we could take a copy of that and run it in an Amazon account for our client. So it's their own thing. It's theirs. It's like in a box. We manage it on their behalf. And so we've got more control. So it's easier for us to maintain it than it is for them because we know how it works. But that can be sort of a halfway between the two, which is effectively a single tenanted SaaS model. I wrote up a bunch of stuff for this on my website. But yeah, on-premise installations is hard. And yeah, I'd say it's got to come from the customers to make that sort of change. And there are some problem spaces where this isn't going to shift, right? There are some types of incredibly latency-sensitive operations where this isn't going to change. There are also some things that are concerns around data. If you're handling very sensitive data, I was working with one client that was doing natural language processing of on-company premise data, and the model they came up with, which is our software gets installed onto their premise, but we manage it on their premise on behalf of them, because it was quite a complex piece of software. So they effectively ran it inside a DMZ. So you've got some models like that that can help. Cool. I've probably time for one more question, and then we should call it a day. Okay, thank you so much for your time. Thanks for coming along. Thank you so much for the host for organising all of this, and Knowit for having me over. Otherwise, I wouldn't be here, so it's thanks to them. I am going to be back for NDC Oslo later in the year. I'm also doing a bunch of the conferences around the world. There's an events page on my website if you want to. I don't know why you'd want to. You can just watch me online. It's cheaper. But thanks for your time, and I hope you have your safe travels getting home.